Today we will be completing Practice Exam 1. Note that problems 1 through 6 on this review are going to be 13-14 questions, which will count to your 13-14 grade. The first section says to sketch the graph of the given equation by plotting points. Complete the G-chart below and show all your work. So I have a quadratic equation here, so we know it's going to be U-shaped. And I'm going to just plug in the values, -2, -1, 0, 1, and 2, in for x. Some students will ask me, are the -2 through 2 going to be there on the test? If they're like this on the review or the practice exam, then they're going to also be the same way on the exam. So if you had that question. Notice I'm just rewriting the equation without an x, because I want to come in and plug in a new x. So for the first one, I have x is -2, so I'm going to go ahead and plug -2 in there. For the next one, x is -1, and then 0, and 1, and 2. And then I have to go back and evaluate each one of those. So -2 squared is -2 times -2, which is +4. 2 times 4 minus 3, that's 8 minus 3, or 5. Let's do it again. -1 squared is -1 times -1, which is +1. 2 times 1 is 2 minus 3. I'm using my PEMDAS here. I get -1. 0 squared is 0. And 2 times 0 is still 0. And 0 minus 3 is -3. 2 more to go. 1 squared is 1. 2 times 1 is 2. And 2 minus 3 is -1. And 2 squared is 4. And 2 times 4 is 8. And 8 minus 3 is 5. So now I'm going to take these points and I'm going to plot them. Starting at the origin, I'm going to go left 2 to get to -2 on the x, and up 1, 2, 3, 4, 5. Once I do both the x and the y direction, then I plot my point. So the next one's -1, -1, that's left 1 and down 1. 0, that means left and right nothing, but down 3. Right 1 and down 1, and then 2, +5. And this looks very symmetrical, which is nice, and I just connect it with a nice U shape. Make sure it's not pointy at the bottom. Okay, the next one looks like a square root function, so that means that my square root is going to usually look like a U shape on its side, but 1/2 of it's cut off, often like that. So let's see here. If I take y equals the square root of x, but instead of x, I'm going to leave a little space there. And then for that space, I'm going to plug in my values. In this case, -5. And let's go ahead and do all of those. There's only 4 in this problem, so I'm going to repeat this 4 times. And then I'm going to plug in the values. -5 for the first one, which we already did. -4, -1, and 4. Now I'm going to take -5 plus 5 is 0. What's the square root of 0? 0. -4 plus 5 is the square root of 1, and the square root of 1 is plain 1. -1 plus 5 is the square root of 4. Now the square root of 4 is 2, because 2 times 2 is 4. And 4 plus 5 is 9. The square root of 9 is 3. So I can plug these values in here. -5, 1, 2, 3, 4, 5, 0. -4, +1. -1, +2. And then +4, +3. So there is my square root problem. On the next section, it says to state whether the relation is a function, and then identify the domain and range of that graph. So in order to determine if it's a function, you take a vertical line and you pass the vertical line through the function. Now, it's hard for me to show it, but if you just take your pencil and then move it horizontally, at any one point it's only touching one part of the graph. There is no place on the graph where it's actually touching 2. So this passes the vertical line test, so the answer is yes, it is a function. For the domain and range, what I'm going to do is I'm going to take my arrows and remind myself that my arrows, even though they're going kind of diagonally, they are going up and out at the same time. So the domain, that's left and right. This is the x values right here. So how far left can you go? Negative infinity. How far right can you go? Positive infinity. And so that's your answer. The range, this is the y's, are up and down. So how, again, all of these are always low, comma, high. So how low can you go? Well, the lowest value that I see here looks like positive 1. 1 is the lowest value. Now I get a bracket because I'm allowed to include that, but it goes up forever. So because it goes up forever, both of the arrows are going up forever, it's going to be up to infinity. The next one says, is this graph a function? Well, we have 1, all of my x values here, 1, 5, negative 5, and 3. None of those repeat. If one of them repeated, they would have to go to the same y value, but each one of these x values is unique, and no x value is trying to date two different y values, so this is, yes, it is a function. The domain, again, is just the x values, the range is the y's. In this case, because they're just discrete points and not a continuous line like number 3, all you have to do is just list the discrete domain values. It was much harder when there's a line because there's an infinite amount of values and you have to find all of them. In this one, there's only 4, so you just list them. The range in this case is going to be y values. So we have 8, 9, 4, and 8. Do I really need to write 8 twice? Probably not. If you did, you're not going to lose any points, but kind of seems redundant, so I'm not going to do it. Is it okay that the 8 was repeated for the function? Sure it is. 1 is trying to date 8, 3 is trying to date 8, and the y values can date more than 1 at a time. It's the x values that always have to be mapped to only one y value. I'm not sure why that little line is there on number 5, but let's just go ahead and ignore it. In this case, is this graph a function? Well, no, it's not. If you pass a vertical line through it, almost every single vertical line is trying to date someone on the north side and someone on the south side. That's not okay. So this is no, not a function. The domain, again, because it's a line, is all the values, how far left they can go, comma, how far right. The leftmost x value looks like negative 1. The rightmost y value appears to be 9. You can include both of those because there's not an open circle there. The y values, the range, again, there's no arrows, so you don't have to worry about arrows. Because there's no arrows, you know there's not going to be infinities. Infinities only happen when you have arrows. So here, how low can you go? It looks like negative 4 is as low as I can go. Comma, how high can you go? 6. Again, numbers get brackets unless they have an open circle. Alright, last one. Is this graph a function? Okay, so this isn't technically a graph, it's just a relation here. So let's look at all the x values. Negative 5 repeats. So negative 5 is trying to date 3, but the negative 5 is also trying to date 11. That is a no-no. You're not allowed to have x's dating more than one y. Now, just because it's not a function doesn't mean it doesn't have a domain. The domain, again, is just all the x values. So I'm just going to list all the x values. 5, 4. Negative 5 pops up twice. I'm not going to write it twice. Technically, you can. It's just kind of redundant. For the range, which is the y's, I got 3, 6, 11, and 13. So notice that there are more ranges than there are domains. If there are ever more ranges than there are domains, you know that's a dead giveaway that you can't have a function there.